Okay, so here we go. We're doing number 4 on the vectors assignment, and we are looking for the total displacement of the spaceship as it travels, vector A and then vector B. And so what I'm going to do is I'm going to, for my Y on these, remember we're doing vector diagrams, so I'm going to grab this picture just because I don't feel like copying it. And that I will put in my Y section here. This is number 4. And nicely, A and B are already arranged tip to tail. And so A, the tail of A to the tip of B will be my resultant. Let's call it vector C. And that will be, C is my displacement. Remember, my displacement by definition is how far I am from where I started and in what direction. So from I start at the tail of A, I finish at the tip of B, and so my displacement is the vector sum of A plus B, which equals C. I want to do it with components. I could do this with doing a non-right triangle. You're welcome to do that. Law of sines, law of cosines. But I'm going to do it with doing it with components to make things, the mathematics, a little easier. So what I need to do are the components of B here, which would be a vector in the x positive direction and a vector in the y positive direction. They tell me this angle is 70 degrees. Everyone has that same angle, right? Because it's in black. Things that are different are the lengths of A and B here. So I flip back here, and my A is 3.1 times 10 to the 6 kilometers, and my B, let's see, this and then my B is 1.1 times 10 to the 6 kilometers. Those are the numbers you guys have differently because they're in red, right? So when you're working through this, use your numbers rather than my numbers, right? So what that's telling me is this: my A is 3.1 times 10 to the 6 kilometers. And actually, I'm gonna, I could write these down in the Y also, but I'm gonna put them up here. And that this is 1.1 times 10 to the 6th kilometers. If I look at my large overall triangle here, okay, and the hypotenuse of that large overall triangle is C. My right angle is here, and then the vertical component is made up of my vertical component of B, and my horizontal component here is made up of A and the horizontal component of C. So basically, I'm going to add up everything that points in the x direction and get my horizontal component of my final. And I only have one thing that points in the y direction, so that's going to end up being that. So my next step would be to find what are these components of B so that I can combine them with A and get my final vector. Yeah. How do I what? Sorry, I just couldn't. Right. That's one of the nice things about using this for our homework is that everyone has their own unique numbers. So that's why, I'm going to work all the way through and check my answer. It'll be different from your answer, so that's why you want to work in parallel with it. Yeah. Or with your classmates. Work in parallel with them. All right, so I have a right triangle here with B, So I'm thinking SOHCAHTOA, right? And so I know that sine, I'm going to move one thing. Just going to move that down, like myself. A little more room. So I'm thinking sine of the angle, which is 70 degrees, equals opposite. Let's call this B sub y, and we'll call this B sub x, saying, hey, this is the x component of B, and this is the y component of B. All right? That's the only reason I picked those numbers, those letters. So sine is opposite over hypotenuse. The opposite is B sub y. The hypotenuse is 1.1 times 10 to the 6th kilometers. Rearrange this so I can get by by itself. I get 1.1 times 10 to the 6th kilometers sine of 70 degrees equals dy. Any questions on how I knew that, what I did that? By is the y component of b. Probably the most common mistake at this point is to forget that your calculator may be in radians from math class. And 70 radians is very different than 70 degrees. I'm going to leave mine in this form so I don't have to do any rounding. And I'm going to do bx, figure out bx. Bx is next to the angle, so that's adjacent to it. So I think as soon as I hear adjacent, in SOHCAHTOA, ka has the adjacent in it, so I think cosine 70 degrees equals adjacent bx over hypotenuse, 1.1 times 10 to the 6th kilometers. And rearrange that, 1.1 times 10 to the 6th kilometers, cosine 70 degrees equals dx. Good? All right. I can turn this because that's easier. Any questions, or ready to move to the combining stage? Yep, and then now I'm going to put these into one big triangle. So my vertical here is by, which is that 1.1 times 10 to the 6th kilometers sine 70 degrees. And my x has two parts. It has vector A, which is 3.1 times 10 to the 6th kilometers, and it has b sub x, which we just said is 1.1 times 10 to the 6th kilometers cosine 70 degrees. And now I'm going to, this is the point, I'm going to pull out my calculator and see what those values are. So 1.1 e to the 6 sine 70 is, for me, 1.0, oops, sorry, not 1 point. 1033661.883 kilometers. So that's my b sub y, or my vertical component of C now. And my other one .158 kilometers. You should have close to but different numbers there. Yes? Now, how many things are there to know about a triangle? How many possible things are there to know about a triangle? Well, let's see. How many sides are there to a triangle? 3. How many angles? 3. Is there anything else? I mean, we could use those then to find like the area of it or the perimeter of it. But those are the 6 characteristics of a triangle. What's nice about one thing about triangles is as long as I know one side and one angle and one other thing about the triangle, I can find everything else about it. So like on this triangle here, I know one angle. I know it has a right angle there between the 2 legs. And I know 2 of the sides. So I know at least one angle, I know at least one side, and I know one other fact. Therefore, I can find out everything else about it. As soon as if I had like all 3 sides, I couldn't find out everything. Because there are a plethora of triangles that have those 3 sides but different angles. If I knew all 3 angles, there's a plethora or an infinite amount of triangles that have those 3 angles but different sides. But as long as I nail down one angle, one side, and one other thing, everything else can be found. So, the things I want to find out about this triangle, I want to find out this angle, because that's what it asked me for. It says, direction counterclockwise from the x-axis. So, here's the x-axis horizontal here. Counterclockwise would be theta. Would be that angle. So I want to find this angle, and I want to find this length of C. Okay? So, I'm going to do the length of C first. And I look at it and say, okay, that's the hypotenuse. Pythagoras tells me that a squared plus b squared equals c squared for any right triangle. And actually the law of cosines tells me that for any triangle with a slight modification. So I'm going to do my values. So for A, I have 3, 4, 7, 6, 2, 2, 2.158 kilometers squared plus 1.103366 1.883 kilometers squared equals c squared. Nice thing about having the TI is you can just arrow up. You don't have to retype them. Don't know how to do that. I can show you that. So I get 3.63 times 10 times 10 to the 6th kilometers. And now let me see if that's right before I move on. You guys should be putting in your own numbers at this point, since you've been working in parallel. Or you can remember it and go back and do it later. I'm going to try putting in mine, so I put in 3.63 e to the 6th. And get my answer. I'll put this one had a tutorial attached, so you can walk through it with the tutorial. And I got it correct. Yay! So I know at least I've done it correctly to this point. You guys saw that tutorial on this one, right? Okay. Yes, it will take it in either one, unless it says give it in scientific notation. But I wanted to, you know, emphasize also the 3 sig figs, so that's why I chose to do it. So now I've gotten the length of my displacement, the magnitude of it, but now I need to do find this angle theta. And actually, now that I have all 3 sides, I could use any part of SOHCAHTOA, right? Because I could use sine, I know the opposite, I know the hypotenuse. I could use cosine, I know the adjacent, I know the hypotenuse. I'm going to use TOA, because if I messed up on a test and did something wrong here, like forgot the square root, at least I'm not basing my answer for this part on something that was wrong. Plus, I haven't used tangent yet, and I don't want it to feel unloved. So, I'm going to say tan of theta is opposite, which is my 1033661.883 kilometers, over adjacent 3476227 no 252. Excuse me. 0.158 kilometers. And I don't want tan of theta, I want theta, so I'm going to do the inverse, or the arctan of both sides, which will get rid of the tan here and leave me with theta here. And the arctan of this whole mess and then I do my calculator. Let's see, so I'm doing inverse tan. This one, divided by this one, and I get 16.6 degrees. Let's see if that's right. Yay! All right, we're gonna go on to number 5. Um, so in number 5, you first had to pick the correct diagram. And what I'm looking for here, let's see. First vector RA points an angle 20 degrees below the positive x-axis. So that's all of them. So no help there. It has a magnitude of 48. The second vector points an angle 43.5 above the positive x-axis, and has a magnitude of this. So let's see. That could be the upper right-hand one. Could be any of them, because all of those are there. But I have to then remember, oh, I'm adding these 2 vectors, so I'm going to put them in tip-to-tail arrangement. So RA and RB in the first upper left diagram are in tip-to-tail. They're not in the upper right-hand one, so I'm going to forget about that one. They're not in the lower right-hand one, I'm going to forget about that one. And then they are also in tip-to-tail in the bottom left-hand one. And then I think, okay, so both these have my RA and RB in tip-to-tail arrangement. But then I remember my resultant goes from the tail of the first to the tip of the second one. Remember, it's tip to tail and then tail to tip. And that's only true in my upper right-hand one here, upper left-hand one, do I go my RA, tip to tail, RB, and then tail to tip, RC? So that has to be my correct vector diagram for it. So that's the vector diagram I'm going to use for my now diagram. So this is going to be number 5. Now I need to get the right information. So the first vector RA points at 20 degrees below the positive x-axis and has a magnitude of 48 meters. So this is 48 meters, the length of this, and this angle here is going to be 20 degrees. I'm just trying to get all my information onto my diagram. You can put it elsewhere. Second vector points an angle 43.5 above the positive x-axis and has a magnitude of 75 meters. So I'm going to put a dotted line here to my parallel to my x-axis. This angle here is 43.5 degrees, and the magnitude of this is 75 meters. I think I got everything correct. And what I want is they're asking me to find the magnitude and direction of my resultant vector. So I'm going to add these two vectors, but to do that, I'm going to do it by components. So what I'm looking for, I'm going to break these out. Let's see. We'll do RA. This is RA. It's going to have a horizontal component and a vertical component. We'll call this AX and AY, and this is 20 degrees. I'm just doing little sub-diagrams to help me organize my thoughts. All right, and then I'm going to draw RB, and it's going to have horizontal and vertical components. This angle will be 43.5 degrees, and this is RB here, and so it will have BX and BY. So these are right triangles. Then I'm going to do a third one just to help me, again, organize my thoughts. RC is going to have a horizontal and a vertical component also. I don't know this angle, so I'm going to call it theta. If RC is RA and RB combined, that means I'm going to add up the components of the two to get the components of the resulting vector. You know, think about adding the numbers like 9 and 4. You could add 4 plus 5 plus 1 plus 3 and get the same answer as adding the two numbers directly together. One of those math things. So my horizontal components here, I'm going to have AX, and I'm going to add to that BX. Notice that I arranged them in tip to tail, right? because anytime I add vectors, I got to add them tip to tail. For my vertical component, I have to do them tip to tail again. And so what I do, starting here, I have AY, which goes down this way. Add to that BY, and I'll get my vertical component of my resultant. And because AY points down there, I'm going to call down negative. You guys okay with that? Down negative, and I'll call it to the left negative. So A and BX are both positive. AY is going to end up being negative, and BY positive. All right? So now let's figure out each one of these. Let's see. Let's do A first. Oh, you're going to be so sick of doing these by the end. So I want to figure out AY. It's opposite my angle. Oh, so it's sine. So AY, I remember, is the hypotenuse. What was my hypotenuse? Mine was 48 meters for A, right? So I get 48 meters sine 20 degrees. And for AX, I'm going to get 48 meters cosine 20 degrees. Pause to make sure that everyone understands how I got those. Yes. Yes, sir. How did I know that right angle was on top? Because they told me the 20 degrees went from the vector, it went clockwise from the x-axis down to the vector. Points at 20 degrees below the positive x-axis. So I knew that this angle here was at 20 degrees. And I'm always going to have a right angle between my components. So I just picked, I could have also, you're right, I could have drawn these components this way, right? The right angle. And then this angle in here would have been 70. And I would have, or this one 20. I could use opposite interior. And end up with the same values. Either way. I just thought this would be more straightforward. Ready to do B's? Let's do B's. So in B's, I have, let's see, 75 meters, right? So my BY is opposite the 43.5. So I get BY equals 75 meters. That's the length of my RB. Opposite is sine of 43.5 degrees. And then my x is next to it, so I get BX equals 75 meters cosine 43.5 degrees. So those are the components so far. Those are the magnitudes of the components. All right. So now I'm going to add up. Well, probably do values. let's see, 48,920. So for AY, I get a value of 16.41696688 meters. DX, I get 45.1052458 meters. DY, I get 51.62659,318 meters. DX, I get 54.403077. I'm going to now grab my triangle here. Go. And now I'm going to add AX plus BX and get the horizontal length of my side as 99.50832363 meters. And I'm going to take BY and add it to AY, but I'm remembering that my AY is negative, right? And so I get a vertical component of 35.2096.263 meters. And any questions on this before we combine these? So we took our vectors we wanted to add together, broke them into their components, added up their components to get the components of our resulting vector. And now that we have those, we're going to use Pythagoras to figure out the magnitude of this resulting vector and tangent again to do the angle of it like we did on the last one. All right? Steven, did you have a... How'd I get h to the y? Back up here, it was opposite, so I did sine of 20. And then I remembered when I combined it with b sub y, that it was negative because it was pointing downwards. That's why it's really important when you draw the components or draw the vectors, make sure you include direction. All right, so let's do Pythagoras, which tells me that RC squared equals my 99.508 squared plus my 35.210 squared. And I get RC, let's see, there's the plus. I get 106 meters. right triangles. And SOHCAHTOA is actually the law of sines for right triangles. Have you guys done the law of cosines or law of sines at all in math class? No. I didn't think you had, that's why I didn't bring them up. But alright, so I got this one so far correct. Now I want to find theta, so I'm going to do tangent again. I'm going to do tan of theta is opposite. That's my 35.210 over adjacent 99.508. And I would solve for theta like I did last time. We will continue this tomorrow, so just keep working on them.